Hello, everybody. So we're getting into the third and the final linear form of our equations here when we're graphing and writing. It's called standard form. Learning objectives for today, I can recognize which equation is slope-intercept, point-slope, or standard form, and I can rewrite equations in standard form. And actually, I want to add another one. I can graph equations in standard form. Let's take a look at the standard form. Let's say we have this equation y equals negative 2x plus 3. With that y being all alone, this equation is in slope-intercept form. If we move that negative 2x to the other side, meaning we're taking that negative 2x and adding it to both sides. Now I have 2x plus y is equal to 3. That 2x plus y equal to 3 is still a linear equation, meaning if we graph this thing, it would still be a straight line on our graph, but it's in a different form. A linear equation in this form, a times x plus b times y is equal to c, is in standard form. Those big capital letters A, B, C, those represent any integer. Any integer times x, any integer times y equals any integer, standard form. If you don't remember what integers are, they're all of our negative and positive whole numbers, which also include 0. So it could be -5, -4, -3, -2, -1, all the way up 0, 1, 2, 3, 4, 5, 6, 7, it keeps going. All the negative and positive numbers. So if you see any of those times x, any of those times y, equals any of those, your standard form. Important to remember, no fractions, no decimals in standard form. We can find the x and the y intercepts and the slope when the equation is written in standard form. In this problem here, the x-intercept is at -2, 0. The x-intercept is when y equals 0. In this graph right here, the y-intercept is at 0, 3. The y-intercept is whenever x equals 0. So they kind of switch like that. They're kind of opposites. If I'm looking x-intercept, my y is 0. If I'm looking y-intercept, my x is 0. And then I can just solve away. We know that y equals 0 at the x-intercept, so we could plug 0 in for y, find that x-intercept. We know that x equals 0 at the y-intercept, so we could plug 0 in for x, find that y-intercept. Basically just what I said. ax plus by equals c. If it's written in standard form, you could use the x and y intercepts to graph the equation quickly. Here's our standard form. If y equals 0, c divided by a gives you the x-intercept. If x equals 0, c divided by b gives you the y-intercept. Shortcut, guys. Remember, I'm lazy mathematician, so I'm always looking for shortcuts. This is a key, crucial shortcut right here. If you could get it to standard form, you take the constant, you take the c, divided by the opposite coefficient, gets your intercept. So if I'm looking for the x-intercept, I take c divided by a, boom, x-intercept. If I'm looking for the y-intercept, c divided by b, y-intercept. Let's take a look at some examples. 6 big examples for today. We have like 2 of each type. The first 2 are these 2 right here, where we're taking equations and rewriting them to be in standard form. This first one here, we have 57 minus 2y is equal to 4x. So we're going to move this thing around to make it look like standard form. In standard form, we want the x and the y together on the same side. So let's move that negative 2y to the other side by doing the opposite, adding it to the other side. They're different variables, so I can't combine them. I just write them right next to each other. I would be okay with you being finished right here, but a lot of the times we want the x and the y first in our equation. Since they're equal to each other, we could switch them around just like this and get our final answer. 4x plus 2y is equal to 57. 4, 2, 57, positive whole numbers. Those are integers. We're done. Standard form. Take a look at number 2. Number 2, we have y equals, so right away we're in slope-intercept form, negative 3 over 7x plus 8. With that fraction right there, we need to get rid of it because we don't want any fractions. We want whole numbers and integers, so either positive or negative whole numbers. With that 7 on the bottom, to get rid of that fraction, you multiply every single thing by 7. Multiply it all by the stuff on the bottom. So now 7 times y gets me 7y. The 7's with the x cancel, and 7 times 8 gets me 56. So now I have whole numbers or integers with that negative 3x. I want to get both x and y on the same side, so I'm going to move that negative 3x to the other side. What's the opposite of negative 3x? Positive, so I'm adding that 3x to the other side, which makes this 3x plus 7y equals 56. Final answer, you got it. Let's take a look at some more. Finding the x and the y intercepts given this standard form. Here we have example 3, 4x plus 2y equals negative 12. Already in standard form. They're all integers. X and y are together on the same side. So we can find the x and y intercepts by plugging in 0 for the opposite value. If I'm looking for the x-intercept, I plug a 0 in for y. So I have everything the same way, except for whatever I saw y, I put a 0 there. Then I simplify. 2 times 0 goes away. So now I have 4x is equal to negative 12. Divide both sides by that 4. My x-intercept is negative 3. Let's do the same thing for the y. When it's the y-intercept, I plug a 0 in for x. So I have everything is the same in the equation, except for the x is now a 0. 0 times 4 goes away. It's just 0. So now I have 2y is equal to negative 12. Divide both sides by that 2. Negative 12 divided by 2, negative 6. So my y-intercept, 0, comma, negative 6. That's the nice thing about standard form. You could really find your x and y-intercepts quickly by using that standard form. Let's do it again. Example number 4. Same thing. This time we have 2x minus 3y is equal to 18. Let's find those intercepts. Keep it in mind that our x-intercept, we plug a 0 in for the y. Y-intercept, we plug a 0 in for the x. So now I have 2x minus 3 times 0 is equal to 18. 3 times 0 goes away. I got 2x equals 18. Divide both sides by 2. I get my x-intercept, 9, 0. Y-intercept, plug that 0 in for x. So I'm plugging it in. 2 times 0 goes away. I get negative 3y is equal to 18. Divide both sides by that negative 3. I get y equals negative 6. So my y-intercept, 0, comma, negative 6. Okay, now let's graph them. My last two examples, let's graph this stuff here. We're looking at example 5. It says negative 3x plus 2y equals 12. I'm going to use the shortcut for the graphing stuff. Looking at these intercepts, I could use those shortcuts. If I'm looking for the x-intercept, I simply take the c value divided by the a value. So I have 12 divided by negative 3. 12 divided by negative 3 gets me negative 4. So on the x line, I put a point down at negative 4. Let's do the same thing for the y-intercept. Y-intercept, we don't care about the x. So I'm looking at the y and I'm looking at the constant, which gives me 12 divided by 2. 12 divided by 2 gives me 6. So my y-intercept on the vertical line is at 6. I have the two intercept points. Connect them with a line. Graphing's done. Let's see it one more time. Our final example for today. This time we're talking 4x minus y equals 8. 4x minus y equals 8. Now, same thing. We're looking x-intercept. If I'm looking for the x-intercept, I don't care about the y. I'm taking the constant, which is 8, dividing it by the coefficient of x, which is 4. 8 divided by 4 gets me 2. So on that x line, put a point at 2. Do the same thing with the y-intercept. I don't care about the x. So now I have negative y is equal to 8. That's 8 divided by that invisible negative 1. 8 divided by negative 1 gets me negative 8. So on my graph, way down at the bottom, I have my point at negative 8. Connect them with a line. We're done. Email me if you have any questions. But guys, this was everything standard form. We converted it to standard form. We found our intercepts with standard form. And then we used them to graph in standard form. Third way of finding our linear equations, the third form. Now we should have it handled. Alrighty, have a good one. See you guys.